This is the second lesson in the transition metals topic. Today we'll be looking at the properties of transition metals and their precipitation reactions. What we will be learning today is why transition metals form coloured ions and why transition metals and their compounds are effective catalysts. We'll also be looking at the precipitation reactions of transition metal ions with sodium hydroxide. So let's start with the coloured compounds. Many transition metal ions have distinctive colours. Everyone remembers the bright blue colour of Cu2+ ion in the copper sulphate solution. This slide shows you some of the other distinctive colours of transition metal ions. You do not need to learn these colours, but just be aware that transition metals form coloured compounds. The compounds of group 1 and group 2 and those of scandium and zinc are all colourless and form white solids. The reasons for these colours is due to the incomplete filling of electrons in the 3D subshell. When white light passes through the compound, some of these wavelengths of visible light are absorbed, and the colour we see is the wavelengths that are not absorbed. At A2, you do not need any further explanation as to why transition metals form coloured compounds, but you can look it up on the internet or ask me if you're interested. A further property of transition metals, in addition to variable oxidation states and coloured compounds, is the ability to act as catalysts. A catalyst speeds up a reaction by lowering the activation energy. Transition metals or their compounds can act as catalysts. They either provide a surface for the reactants to react on, like the catalytic converter in cars that we met in AS, or alternatively, because they can lose and gain electrons, they can bind with the reactants and form intermediates as part of a mechanism with a lower activation energy. Again, you need to know very little detail about how transition metals act as catalysts. I've never seen a question about asking how a catalyst may work, however it may be useful to know a few examples. Iron is used in the Haber process, which is the production of ammonia. It just acts as a surface for the hydrogen and nitrogen to come together on. Vanadium oxide is used in the contact process, which is the manufacture of sulfuric acid. And finally, the addition of hydrogen to unsaturated vegetable oils to form more saturated oils or margarine uses nickel. We're now going to move on to the precipitation reactions of the transition metals. A precipitate is a solid that forms when soluble ions are mixed together. The precipitate has the state symbol S for solid, as it is insoluble. When sodium hydroxide is added to a soluble transition metal ion, a solid precipitate is formed, and the solid precipitate is the metal hydroxide. Sodium hydroxide is often used in analysis because these compounds can be identified through the colour of their metal hydroxide precipitate. You need to be able to write the ionic equations and state the observations for the reaction of copper 2+, cobalt 2+, iron 2+, and iron 3+ with sodium hydroxide. This table shows you all you need to know. It shows you the observations and the equations that take place when you add sodium hydroxide to each soluble transition metal ion. When added to copper 2+, a pale blue precipitate of copper 2 hydroxide is formed. When added to cobalt 2+, a blue precipitate forms which turns beige when left in the air. The precipitate is cobalt 2 hydroxide. When added to iron 2, a green precipitate forms which turns rusty brown when left in air, as it is readily oxidised to Fe3+. And finally, when iron 3 is mixed with sodium hydroxide, a rusty brown precipitate forms. Take note of the state symbols in the equations to show that the metal hydroxide is a precipitate as it has a small s after it. During the lesson, you will be carrying out a qualitative practical where you will have to record observations of different transition metal reactions. If you need to pause and rewatch the video, sorry, I'll say that a little bit again. You may wish to pause the video now and copy down the table of observations and reactions into your notes. The relevant pages in the textbook are pages 206 to 207. And that's all for this lesson, and I'll see you in the classroom.